Imagine a time before time itself. Picture a space so small it makes an atom look like a vast universe. This, my friends, is the singularity. This is where our story begins. In this singularity, all the matter and energy that make up our universe were compressed into an infinitely dense point. The laws of physics as we know them break down at this point. We can't even begin to fathom the temperatures and pressures that existed within this singularity. It was a realm beyond human comprehension. But something monumental was about to occur. This tiny point, brimming with unimaginable potential, held the seeds of everything we see around us today. This singularity wasn't just a collection of stuff. It was a state of being. It was everything, everywhere, all at once. And then, in a fraction of a second, it all changed. The singularity began to expand, and with it, the universe as we know it was born. The Big Bang. It's a name that conjures up images of cosmic explosions, a cataclysmic event that shattered the silence of the singularity. But it's important to remember there was no sound in the vacuum of space. There was no before the Big Bang, because time itself began at that very moment. The Big Bang wasn't an explosion in the traditional sense. It was an expansion, a rapid stretching of space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move further apart. That's a simple way to visualize how the universe expanded from that initial singularity. As the universe expanded, it cooled. Energy, once confined to an infinitesimally small space, began to spread out. And as it did, something incredible happened. Energy began to transform, giving birth to the building blocks of matter. The universe, once a sea of pure energy, was about to take on a more familiar form. In the first fleeting moments after the Big Bang, the universe was an inferno of energy. Temperatures were so high that matter as we know it couldn't exist. But as the universe continued to expand and cool, a remarkable transformation took place. The universe transitioned through various epochs, each marked by a specific temperature range. During these epochs, energy began to condense into particles. First came quarks and leptons, the most fundamental building blocks of matter. These particles collided at unimaginable speeds, creating a chaotic cosmic soup. As the universe cooled further, these fundamental particles began to combine. Quarks came together to form protons and neutrons, the building blocks of atomic nuclei. But the universe was still too hot for atoms to form. Electrons, the negatively charged particles that orbit the nucleus, zipped around at high speeds, constantly colliding with other particles. Section 4. Stellar Nurseries, the Birth of Stars and Galaxies. The universe, once a hot, dense soup of particles, was cooling and expanding. About 380,000 years after the Big Bang, the universe had cooled enough for electrons to be captured by atomic nuclei, forming the first atoms. These were primarily hydrogen and helium, the simplest and most abundant elements in the universe. Gravity, the architect of the cosmos, began to exert its influence on these newly formed atoms. Over vast stretches of time, gravity pulled these atoms together, forming gigantic clouds of gas and dust. These clouds, called nebulae, became the stellar nurseries where stars would be born. Within these nebulae, gravity continued to pull matter inward, compressing the gas and dust at the center. As the pressure and temperature at the core of these collapsing clouds increased, a remarkable transformation took place. Nuclear fusion ignited. Hydrogen atoms fused to form helium, releasing tremendous amounts of energy in the process. The first stars were born, bathing the universe in light for the first time. Section 5. Our Cosmic Cradle, the Formation of the Solar System. The story of our solar system begins within a vast, swirling cloud of gas and dust known as a solar nebula. This nebula, like countless others scattered throughout the Milky Way galaxy, was a product of the Big Bang, enriched with the remnants of previous generations of stars. Approximately 4.6 billion years ago, something disturbed this peaceful cloud, perhaps the shockwave from a nearby supernova explosion. This disturbance caused the cloud to collapse in on itself, initiating the formation of our solar system. As the cloud contracted, it began to spin faster and faster, just like a figure skater pulling their arms in during a spin. This spinning motion flattened the cloud into a disk, with most of the mass concentrated at the center. This central mass, under immense pressure and heat from gravitational collapse, eventually ignited into a star, our very own sun. Meanwhile, in the outer regions of the disk, dust and gas began to clump together, forming planetesimals, the seeds of planets. Section 6. A Spark of Life, the Emergence of Biology. Billions of years ago, on a young planet orbiting a relatively unassuming star, something extraordinary happened. Amidst the primordial oceans and volcanic landscapes of early Earth, life emerged. The exact details of this momentous event remain shrouded in mystery, but we have pieced together a compelling narrative based on scientific evidence. The early Earth was a harsh and unforgiving place. Volcanoes spewed molten rock and noxious gases into the atmosphere, while lightning storms raged across the sky. Yet within this chaotic environment, the building blocks of life were quietly assembling. Simple organic molecules, the precursors to life, formed in the primordial soup of early Earth. These organic molecules, through a process we still don't fully understand, began to self-assemble into more complex structures. Over countless generations, these structures became more stable and organized, eventually giving rise to the first self-replicating molecules, the ancestors of DNA and RNA. These molecules, capable of storing and transmitting genetic information,